Hello everybody, today we're going to talk about approximating square roots. So let's talk about a rational number versus an irrational number first. A rational number is a number that can be written as a fraction. Okay, any number that can be written as a fraction is a rational number. Any number that cannot be written as a fraction is called an irrational number, which basically means that it's a decimal that goes on forever, and it does not have a repeating pattern in it anywhere. So the square root of any number that is not a whole number is an irrational number. So for example, the square root of 4 is 2. That's a rational number. But the square root of 3 is 1.732, blah, 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 blah. Okay, and it is not, it is an irrational number. It's a decimal that goes on forever. It never repeats its pattern. The decimal form of an irrational number neither terminates or repeats. Okay, so here we've got our numbers. We talk about our natural numbers. That's the counting numbers 1, 2, 3, 4, etc. And then somebody came along and added 0 to that, and there's your whole numbers. And then we came along and added negatives to that, and those are your integers. Okay, then we add our fractions. Okay. 1/2, 2/3, 2.25, negative 0.3 repeating. Those are rational numbers. Now, irrational numbers would be numbers like pi, negative 2 pi, the square root of 2, the cube root of 7, negative square root of 3. Okay, and then all of these together are called the real numbers. Okay, so classify the real numbers. Okay, square root of 12. Square root of 12 is not a perfect, 12 is not a perfect square. So this would be irrational. Okay, and it's not a perfect square, so it's a decimal, a non-terminating decimal, let's put it that way. Non-terminating decimal that doesn't repeat. And I ran out of room for that. Okay. Negative 0.25 repeating, so that's negative 0.25, 25, 25, 25 forever. That's a rational number. Okay. It's a decimal, it repeats. So we'll just say decimal repeats. You could write that as a fraction. I can't think of what that is off the top of my head. I think it's 25 over 99. Let's check that really quick. Yes, that's 25 99ths. Okay, so I can write that as a fraction. All right, negative square root of 9. Well, that's just going to be negative 3, so that's definitely a rational number. It's actually an integer, and all integers are rational numbers. Excuse me. Okay, pi is irrational. You cannot, it's the same as this one, so we can take this. And just move it down here. Okay, and then 72/4. Well, that's obviously a fraction, so that's a rational number. It's a fraction. Okay, so there we go. Excuse me. All right, now you classify these. So take a second, pause your video, check and see. What do you think? Are these rational or irrational numbers? Ready, set, go. Okay, so this first one right here, 0.12, 122, 11222. Okay, this is not a repeating pattern. So, and it goes on forever. That's what those three dots mean. So this is irrational. Negative square root of 196. That is negative 14. So that's definitely rational. It's actually an integer. The cube root of 2. Okay, so the cube root of 2, we can do that on our calculator. So if you want a cube root on your TI-84, you can just push math and then go down to number 4, hit 4, and that gives you a cube root, and then you just put a 2 in there and hit enter, and it's like 1.2599210.5. And it keeps going, there's no more digits in the calculator for that. So this is irrational. Okay, so you should have got irrational, rational, and irrational. Okay, now estimating a square root. So the square root is 71 to the nearest integer and the nearest tenth. Okay, so here's the thing with this. You should be able to kind of estimate it to the nearest integer. Okay, to the tenth. You know, if you're close, I have no problem with that. If you really need to be accurate, you're going to use a calculator, and that's what I would do. So, here's the thing, is to estimate these square roots like this, you're going to want to know the perfect squares. Okay, so what are the perfect squares? Perfect squares are 1, 4, 9, 16, 25, 36, 49, 64, let's see, 81, and 100. There's the first 10, okay? You should know those. You should know those first 10. Okay, so, what's a perfect square? Well, this is 1 squared, 2 squared, 3 squared, 4 squared, 5 squared. If you take the square root of any one of these, you get a whole number. Okay? So you can look at this and go, okay, well, let's see, square root of 71, that's going to be between the square root of 81 and the square root of 70 or 64. So it's going to be a little bit more than 8 and a little bit less than 9. So you got to kind of guess where it's going to be. So if the first answer is easy, well, actually, A to the integer, that's 71. It's going to be a little bit closer to 8 than it is to 7, so I would say that this would be 8. Then you got to kind of guesstimate where it's going to be. So I'm going to say that this thing, I would guesstimate that this is about 8.4. Okay? It's a little bit closer to 64 than to 81. If I really want to know this, I'm getting out my handy-dandy TI-84 plus C Silver Edition graphing calculator, or some reasonable facsimile thereof. And I'm going to put in square root of 71, hit enter, and it's 8.426. Okay, and so on. It's not exactly 8.426, but that was a pretty good guess. Okay. Now, which is greater, the square root of 5 or 2 2/3? Okay, so the square root of 5, if I look on here, that's pretty close to 4. It's a little bit bigger than 4. So, but it's way less than 9, relatively speaking. So this thing is going to be very close to 2. I would guesstimate about 2.2. So square root of 5 is approximately equal to 2.2. So I would say that this is bigger since that's closer to 3. Okay, so let's check it out and see what we got. So the square root of 5 is 2.236. Okay, so this is the bigger number. Okay. The radius of a circle with an area A is approximately the square root of A divided by 3. The area of a circular mouse pad is 51 square inches. Estimate its radius to the nearest integer. Okay, so it tells me that the radius is approximately, and I should use approximately signs, okay, the square root of a divided by 3. Okay, so if the circular mouse pad has an area of 51, the radius is approximately the square root of 51 divided by 3. And 51 divided by 3 is 17. So this is about the square root of 17. Let's see. The square root of 16 is 4. So this is going to be approximately 4.1, and this is in inches. Okay, so there's my estimate right there. Let's see how close I got with my square root of 17. Square root 17. Enter 4.123. Okay. And you know what? Getting good at approximating square roots just takes practice. The more practice you have, the better. The distance in nautical miles you can see with a periscope is 1.17 times the square root of h, where h is the height of the periscope above the water. So if we look at this picture here, that distance right there is h. Can you see twice as far with a periscope that is 6 feet above the water than a periscope that is 3 feet above the water? Okay, well, let's figure that out. So the first one, we'll figure out the distance is going to be 1.17 times the square root of 6. And the other one, the distance is going to be 1.17 times the square root of 3. Okay, so let's just figure these out. So this would be something I would use my calculator for. 1.17 times the square root of 6. This comes out to be approximately 2.86, we'll go 59 miles, nautical miles. Now, what's a nautical mile? A nautical mile is, I think it's a little bit longer than a regular mile. It's close, but it's not the same distance. I can't remember if it's longer or shorter. Okay. I believe it's longer though. So now we'll take 1.17 times the square root of 3, and we're going to get d is approximately equal to 2.0265 nautical miles. Okay, so the question is, can you see twice as far? No, you can't. You can only see not even half as far again as this one. So the answer would be no. I would say you can't even see half again as far as the 3 miles. Okay, now let's kind of look at why that is. I mean, if you look at these formulas, the 1.17 is the same. The only thing that's different is the square root of 6 and the square root of 3. So if I take the square root of 6, that's 2.449. And then the square root of 3 is 1.73. It's not twice as much bigger. Okay? So this is not going to be twice as big as that. Okay. So you're going to do a couple of these real quick. So pause the video. Tell me which number is greater, 4 1/5 or square root of 23, and the square root of 2 or negative square root of 2 or negative 2. So pause the video, then jump back on. Okay, I think we can do this one first because that's by far the easiest. The square root of negative 2 is going to be larger than the square root of negative 2. Now, the only reason that's confusing is because it's negative, but you remember on a number line, here's 0, there's negative 1, there's negative 2, okay? And the negative square root of 2, that's about 1.41. So that's going to be like right here. Okay, and then negative 2 is right there. This is the bigger number. Okay, now let's look at this one over here. So the square root of 23, we can approximate that. So let's see, square root of 25 is 5. This is almost 5, but not quite. I would say this is approximately 4.7. That's what I'm going to guess. Maybe 4.8. Okay, so this is going to be the bigger one, square root of 23. All right, let's check that out. Square root of 23, 4.79. So actually, this was actually closer to 4.8. Okay, and 4 1/5 is 4.2. Exactly. So that's the bigger one. Okay, you're going to get to do problems 1 through 53 odd, and I will see you guys in class.